Hi everyone, so I'm Dheeraj and I'm your chief mentor for mathematics, for gate data science in AI, for computer science, for electronics and communication, electrical engineering and instrumentation branch, as well as for aerospace engineering, right? So I'm going to solve this question. Many students have been asking me, please sir, give a solution for gate data science and AI paper. So I decided to take up this question from neural network, right? So if you don't have any sort of knowledge about neural network, but if you watch this video till the end, you will be able to solve this question, right? So before I get started solving this question, right? This question was asked. Let me give you in GATE DA paper in 2024. Okay, from the neural network topic. So let us go through the question. Though I'm not going to get started solving the question unless I cover some of the basic thing that you need to solve this question, right? So consider two neural network they have given, the figure 1 and the figure 2. Okay, and they have given some activation function, and R denotes the set of real number. The connection and their corresponding weights are shown in the figures. The biases at the every neuron are set to 0. Okay, for what value of PQR in figure 2, okay, are the two NN equivalent? So you have to compare these two neural network. Okay, they must be same. Okay, but in this case you see there is a three input. We have got three input here. Okay, and in this case you see there is a layer of neurons. Okay, so first of all let me start with the three inputs and single neuron will be there, right? So first kind of background that you need is neuron with three inputs. Suppose we have got neuron, okay, with three inputs. So what is the job of neuron mathematically that we have to understand? So if you are learning neural network from the scratch, okay, then only you can solve this question. This question belongs from the scratch. If you have the knowledge, then you can solve the question, right? I mean, from the scratch, just a basic knowledge. So neurons with three inputs means, suppose we have got, this is a neuron. I'm talking about artificial neuron. Okay, I'm not talking about biological neuron. Okay, so we have got this neuron and there are three inputs. Okay, so you see this is one input x1, x2, and there is third input x3, and there is a biasing also. You can say bias term is also present, that is b. Okay, but in the question they have mentioned the bias is set to be 0 at the neuron, right? So what is the job of this neuron? Okay, this is a neuron. Okay, remember this is a neuron. What is the job of this? So this input will be having the corresponding weight also, w1, w2 and w3. Okay, these are the weights corresponding to each inputs. Okay, suppose you are increasing the number of inputs, so these weights will also increase, but bias will not increase. Okay, bias is going to be same. Now what is the job of this neuron? Okay, mathematically this neuron is going to take the input, okay, multiply with the weight and sum them up. Okay, so basically this neuron is going to perform this summation operation. Okay, so I'm just going to write here, you see x1 times w1, x1 times w1 plus x2 times w2 plus x3 times w3 and plus biasing term. Okay, that bias will be present here. Okay, in the question they have mentioned bias is set to be 0. So what is the job of this neuron, guys? You have to remember this is the artificial neuron and it is going to perform this summation operation. Okay, this is nothing but a summation operation. Okay, summation. So in summation you have to take the input, multiply with the weight and you get the output, right? So this neuron is going to perform this summation operation mathematically. It takes the input and multiply with the corresponding weights w1, w2, w3 and then sum them up. Okay, so this is a structure you have to remember, okay, in order to solve this question. So I'm talking about neuron with three inputs. Suppose let us increase the number of inputs. So if we are going to increase the number of inputs, what will happen? The weight is going to increase also. So now next structure I'm just going to talk about is, okay, the neuron with four inputs. What? Neuron, okay, with four inputs. Understand? Neuron with four inputs. Suppose we have got neuron here and there are four inputs, 1, 2, 3 and 4. So x1, x2, x3, x4. See, these things you can do using numpy, right? There is a Python library. We have got numpy, okay? But since there are less number of inputs, okay, and there is a neuron here, you can sum them up, okay? And corresponding weight is nothing but W1, W2, W3, okay, and W4. And there is a biasing term as well. You can say B. So what is the output, guys? Output is going to be, this neuron is going to sum, okay, sum the corresponding weight times the input x1 W1 plus x2 W2 plus x3 W3 and plus x4 W4 plus the biasing term. Okay, bias. There will be bias, okay? Understand? So neuron with 4 inputs and neuron with 3 inputs. I hope this makes sense, right? So what you can do here is you can also write a code. Neuron with 3 inputs, you can implement. You can implement this, okay? Neuron with 4 inputs also. Understand? But what I'm going to discuss here is I'm going to talk about layer of neurons. Okay, I'm just going to talk about layer of neurons. Understand? So first code that you have to write is nothing but neuron with 3 inputs, then neuron with 4 inputs. Okay, in the question you might have seen activation function, everything is given, but we don't have to worry about that because this question is asked in the gate examination. You have to get the answer simply, right? Having some basic background. Understand? So what is this layer of neurons? Layer of neurons. So instead of having single neuron, here single neurons are there. We can have many neurons, right? Okay. Suppose we have got one neuron, second neuron, three neurons. There are three neurons, okay? This is called layer of neurons. And we have got inputs. Okay, so we have got 4 inputs here. You can say x1, x2, x3, x4. Understand? And these inputs have the corresponding weight also, right? So we have got 3 neurons, number 1, number 2, number 3. Okay, now suppose these are the inputs. You can say x1, x2, x3, x4. And what is the job of neuron mathematically? As I told you, neuron takes the input, multiply with the weight, and it is just going to add. Okay, if suppose bias is 0, so it is going to perform the linear combination. That's it. I mean, the weight times the input gives the output. Okay, understand? So please do remember this. Understand? So suppose this x1 correspond like x1 goes to neuron 1, right? And corresponding weight is going to be w, you can say 1 1. Okay, w11, and this also correspond to goes to neuron 2, it goes to neuron 3, you can say. Understand? So this is going to be w12. You have to focus on this subscript here. Okay, these. Okay, so first input goes to the second neuron, okay, first neuron, and it will also go to third neuron, right? And in the same manner you can say that second input goes to first neuron, second neuron, and third neuron. Third input goes to, you can say, first, second, and third. Fourth input goes to first, second, and third. And you can define the corresponding weights as well. Okay, and there are bias. Okay, you see bias term will be there, right? So you can say there are 3 neurons, so it is having the bias b1, b2, and b3. Okay, so what does these neurons, okay, what these neuron is going to do? So these neuron will perform the summation operation. Okay, they will take the input corresponding with multiply and add it. Okay, so I'm not going to write for all, you can say. I'm just going to write here. So you can say here x1 times w11 plus x2 times, you can say that w21 plus x3 times w31 plus x4 times w41. Okay, these are the weights. Okay, we are coming from fourth input to the first neuron. You can write also this, and you can also write this. Okay, so this is nothing but a layer of neurons. Understand? So this question was based on these three building blocks. If you know, okay, from the you can say artificial neurons, you can solve this question. I'm just going to solve it, okay, for you. Dekho, let me come back to the question. So you see, read the question again. We have got these two neural network and we have to make the equivalence. I mean, both neural networks are same. Understand? So you have to simplify first of all. The this is nothing but a layer of neurons. This is also a layer of neurons. Okay, they have connected. Okay, two neural network. I mean, layer of neurons they have connected here. Many layers are there. Okay, so what you can do here is since they have also mentioned in the question the bias at every neuron is set to 0. No biasing is there, right? No biasing is there. So what you can do here is you can consider this neuron is number 1, second, and this is third, right? And you can also say that this is nothing but, suppose this is input x1, right? Okay, so you can say that this is you can take anything. You can say this is x1 dash, x2 dash, and x3 dash. Okay, just to so that we can write in terms of x1 dash, x2 dash. Okay, so output of that x1 dash, x2 dash, and x3 dash. So what is x1 dash, guys? X1 dash is going to be the x1 plus x2. Okay, why? Because x1 is coming to neuron, first neuron, x2 is going to first neuron, and the weights are one only, simple. And what is, guys, x2 dash? You can say the second at second neuron the output is going to be only input x1 and x3 is coming, so you can say that x1 plus x3, right? And x3 dash is going to be, you see, you have to follow the arrow also, right? So here x1 is coming, x2 is coming, x3, so everything is coming x1, x2, x3, sum of these. Okay, and the bias is 0. Yeah, it's good thing, right, if the bias is 0. Okay, so we have got x1 dash, x2 dash, x3 dash. Now what you can do here is you can come to these neurons, right? So I'm just going to put x1 double dash, x2 double dash, right? So what is x1 double dash in terms of x1 dash? So x1 double dash in terms of x1 dash is nothing but what? 2 times x1 dash, okay, plus 2 times x2 dash plus, x3 dash is also coming, so you can say 2 times x3 dash. Now what is x2 double dash? X2 double dash is going to be, so I think I must write here, you might not be able to read it. Okay, so just wait. Here I'm going to write, okay, everything. So you can say x2 dash double dash is nothing but x1 dash 2 times of x1 dash plus 2 times of x2 dash 2 times of x3 dash, right? And I mean, this is nothing but x1 dash double dash. Okay, we are at these neurons. Okay, now we are writing the output of this neuron. So x2 double dash is nothing but, you see, everything is coming here, all three inputs. You can say these are the inputs now for these neurons. So this input, this input, this input. Okay, so you can say that 2 times of x1 dash plus 2 times of x2 dash plus 3 times of x3 dash, sorry, 2 only, right? Now you can say this is nothing but x1 double dash, triple dash, you can say. Okay, so what is this x3 triple dash? That is going to be 3 times of x1 double dash plus 3 times of x2 double dash, right? Now you have to write this x3. Suppose this correspond to x3 triple dash. Okay, this correspond to x3 triple dash, and you have to write x3 in terms of x1, x2, x3, right? So what we can do here is, I'm just going to switch to next page. Okay, I'm just going to add one page here, right? So needless to worry, yes. So this is this, I'm just going to take this picture. Okay, remember. So suppose we have got we have to write x3 triple dash in terms of pqr. So p x1 plus q x2 plus r x3. Okay. Now we have to convert this equation, right? We have to convert this equation in terms of x1, x2, x3. So I think you can replace x1 double dash from the from these this equation and this equation, right? Okay, so it becomes 6. Okay, because 3 you can take common, and from here you can take 2 common, right? So if you plug here, okay, so it becomes what? 6. Understand? So I'm just going to plug everything, you see. So x3 double triple dash is nothing but 3 times 2, okay, times, in place of x1 double dash you have to write this, which is x1 dash plus x2 dash plus x3 dash, and again you can 3 times 2, which is nothing but again x1 dash plus x2 dash plus x3 dash. Okay, so what is this? 6 common you can take, and further 1 plus 1, that is 2 only, right? So it becomes 12, right? Okay, it will give you 12. Understand? So 12 times x1 dash plus x2 dash plus x3 dash. Now what you can do, in place of x1 dash you can replace these, okay, this equation. So you can plug here, so it is nothing but x3 double dash triple dash is nothing but 12 times, this is x1 plus x2 plus this is x1 plus x3, then x1 plus x2 plus x3. Understand? So you have to just simple algebra is there, that's it. So x3 triple dash is nothing but 12 times, you can just add x1 plus x1 plus x1, that is 3x1 plus 2x2 plus 3x3. Okay, sorry, 2x3 only, right? So now you can compare this and this. You have to compare this and this. Okay, so if both are same, it means the output of both neural network is same. The answer is, then you can get the answer PQR. Okay, so 12 3 ja, you know 36 x1 plus 24 x2 plus 24 x3, right? So what is the value of PQR? PQR, right? So P is gonna be 36, Q is going to be 24, R is going to be 24. Okay, so this was a very easy question, right? Option A is gonna be correct for this question. So if you have a background, okay, some building blocks, okay, I have chosen these x1 dash, x2 dash, x3 dash, okay. They are going to act like an input for layer of neurons, okay. Understand? Because here layer of neurons are connected, you can see here. Understand? So input of this x1 dash, x2 dash, x3 dash, they are going to become an input for x2 double dash, x2, x1 double dash, x2 double dash, right? So you can choose A, B, C, D also. I don't have any issue, right? You see what we are doing. We are just following the what neuron does, artificial neuron does mathematically. Okay, so you will get the answer. So I hope you might have enjoyed this solution. And in this question they have given the bias term 0, right? You can also implement these neural network using numpy, okay, and you will get the answer very quickly. But in the gate examination you don't have to program anything, you don't have to write any code, you have to do like this. Okay, so thank you so much. We'll meet in the next session with another question and detailed solution, right? So please do watch this session. Okay, if you're going to spend around 15 to 17 minutes, you will get complete insight of this question. Thank you.